Hello fellows, welcome to Mathematics with MATLABs. Today we'll be focusing on Mathematics Paper 2, taken from the question paper, Department of Education, November 2018. So we'll be looking at suggested solutions for question 3, and this will be analytical geometry, grade 11, and it is presented by me, your teacher, Matlabiani, MS MATLABs. Let's get right into it. Right, in this question paper, you are given a diagram. Every time you check your diagram, when a diagram is given, every information that will be written, it will be based on the diagram. It means it informs you of what is actually happening with the diagram. But before you even look at like the information that comes along with the diagram, we can come up with certain things here. You see, first of all, we can see that we have a quadrilateral here, quadrilateral A, B, C, D. We can see we have two diagonals here, which is AC and BD. We can also see that we are given points. Some points actually have X coordinate and Y coordinate. Like for an example, you have both coordinates for A, you have both coordinates for B, for C, but something is happening here at D. You see, you do not know the value of X, you also don't know the value of Y, and we can also tell that N is an X-intercept because this line AD is actually cutting the negative X-axis at N. This is a typing error. This is not the Y-axis, the X-axis, and this is the Y-axis, and we can also tell that this is the origin, and at the same time we can also tell that BA or actual BA is produced to E, which is also an X-intercept. You see, but we don't know, we know nothing about E. The only thing that we know is that at E, Y is equals to 0, because the only time you can have a point on the Y-axis, on the X-axis, is when Y is equals to 0, and the only time you have a point on the X-axis is when, on the Y-axis is when Y is equals to 0. So we are in a way very happy to say we are expecting that at some point we should determine the value of t, and at some point we should determine the value of x and y. And another thing that we know is that at the point of intersection, the equations that defines the lines that actually intersect are actually equal at that particular point. So as long as we are having two unknowns, it means we need two equations in order to solve for x and y at the same time. Understand? So now let's get into it. Let's check the question. Our question says, in the diagram, A, B, C, D are the vertices of a quadrilateral having, which is very obvious, AD is parallel to BC, and these points of the quadrilateral are actually having those coordinates like I've already indicated. But every time you should check, you see when we say B is 6 and 5, sometimes the question will, sometimes there is a typing error. You find that it is B but it's written minus 6 and 5. You should check if whether the signs of the X and the Y values are really in that particular quadrant. Like for an example, we know in the first quadrant x must be positive, y must be positive. In the second quadrant, y must be positive and x must be negative. In the third quadrant, both of them are supposed to be negative. And in the fourth quadrant, x is supposed to be positive and y is supposed to be negative. So by default, we are actually saying if there is a question that would say we should calculate the value of x and y, we already know that x must be negative and y must also be negative. And at the same time, because this AD is cutting the x-axis on the negative side, it means the t must also be negative. Okay, and we can also see that M is actually an intersection of the two lines, which is AC and BD. So now let's look at it. It says BA produced has an x-intercept at E, which is obvious, is the one that you see here, and then BD and AC intersect at M. Okay, N has those coordinates. We don't know the value of x. Is a point on AD. Right, now let's check the questions that come along with this diagram. Okay, we draw a line there. Let's check the first question. But before we check the first question, let's underline the important aspects of the question, like D. We already know something must happen with this D, having coordinates x and y, and this AD parallel to BC must actually tell us something to say, okay, what do we know about parallel lines? We know that parallel lines, we can't be saying parallel lines are lines that will never meet, but that will not help us with anything. But we are in an analytical context. Therefore, it means we are looking at parallel. We will actually look at the gradient of AD and the gradient of BC. We know very well that parallel lines have the same gradients. This is what this is telling us. Okay, by default we are saying the gradient of AD is the same as the gradient of BC. So if we know one of the lines, then we know the gradient of both of them. Okay, and another thing, it's this point. It's very important because it's an x-intercept, and at the same time we need the value of t there. Right, so let's check the question. Question 1, calculate the gradient of BC. How many marks will this question have? Just check, it's 2 marks. So you see, every time when you answer your questions, grade 11s, to me, you are not a grade 11, you are actually a grade 12 in the making. Okay, because the very same questions that we are answering now, these are the same questions that you'll find in grade 12. These are the same questions you'll write in the final examination in grade 12. So let's make sure that we understand everything, okay, step by step. Now, let's check. It says calculate the gradient of BC. By default, you check gradient, and you remember in analytical geometry you have gradient formula, so it means that is supposed to work. And this is 2 marks. So 2 marks means you are not supposed to spend more than 2 minutes on this question. If you spend more than 2 minutes on this question, it means there is something wrong. It's either the question is wrong or you are the problem to the problem. So when you are given a problem, don't become the problem to the problem. You should become a solution to the problem. Okay, as a result, it means you'll not spend more than 2 minutes on this one. Okay, now there are 5 steps every time where I tell my students to say there are 5 steps in analytical geometry. 1, you label your coordinates. After labeling the coordinates, you choose the correct formula out of the gradient formula, distance formula, midpoint formula, equation of perpendicular lines relative to gradients, equation of parallel lines relative to gradients, so on and so on. Then after writing the formula, you substitute, then you play your maths. It means you use your calculator, then from there you find the solution. And your solution must always be in the simplest form. Okay. Now let's check. With this question, is going to be very easy. You should remember that we are dealing with line BC. People, it's advisable that you use colored pencils when you answer analytical geometry problems. Using a colored pencil doesn't mean you are a child. It means you want systematic solutions to the problems that are given to you. Okay, so now I'm highlighting this one, BC, because it's the one that we'll be dealing with. So it becomes very simple because we know the coordinates of both. Okay, so let's start with the first step. You label, you get x1 and y1. You also get x2 and y2. It is not compulsory that the value of x at c should be x1. You can still make it x2. It depends on which position you want, which point you want to start with. But because I know in the formula I actually have x2 minus x1, it is easy to say 6 minus 0 than 0 minus 6, because with 0 minus 6 I'll be working with negative numbers, which might be a bit problematic in my computation and calculations. Okay, so you can name them the way you like, but it is wrong. You can't say x1 y2. So ones will go along, will go together, and twos will go together. Okay, so immediately after labeling, which is your first step, then you write the formula. So here is your formula. We need the gradient. Remember, small letter m represent gradient. It's gradient of line BC, which is equals to y2. This is changing y divided by changing x. y2 minus y1, and then x2 minus x1. Then from there, if you are able to label your points, your endpoints, and then you choose the correct formula, then you're done. You substitute the values. Okay, you substitute the values. y2 is 5 minus, remember this minus is minus for the formula, and then every time put the next value, put the y1 in brackets, whether it is positive or it is negative, put it inside the bracket so that you always remember. Because if you don't put brackets here, then your solution is going to be wrong. So you have 5 minus into minus 3, okay, divided by 6 minus 0. Remember, negative multiplied by negative will give you positive, okay? And then that positive will result in 5 plus 3, which is 8 divided by 6. And this will give you 4 divided by 3. It is also important to know how this is marked, you see, because the examiner will actually give you a question, but you need to know where you're going to get the marks. Like for an example now, you'll get a mark for, not for substitution, you get a mark for substituting into the correct formula. That is why it is important for you to start by writing the formula, so that we know you are substituting in which formula. Because if you write a wrong formula and you write this step, then there will be no logic. There will be no relation between the formula and what you are having here. So you get a mark for substituting into the correct formula. Okay. And then from there you play your maths here, and then you also get a mark for the final solution. How hard is that? Very simple. Okay. Now, let's also remember that questions in mathematics do not exist in isolation. What do I mean by that? They are like the beads of a necklace. They blend like musical chord. It means one beat must be connected to another one, just like that. So it means the succeeding question will rely on the preceding question. So when we have the gradient of BC in 3.1, it means it must help us in 3.2. Whatever we get in 3.2 must actually help us in 3.3, so on and so on. So there is no way in which you can actually answer 3.3 without using the information that you actually calculated in 3.1 or 3.2. That is why I'm saying they do not exist in isolation. Okay, they scaffold one another, they piggyback one another. All right. Now let's look at the second question. Remember, this is how you get your 2 marks. Okay. Then 3.2, determine the equation of AD. And this is 3 marks. Equation. You underline the word equation of AD. What is AD? AD is a straight line. And a straight line is given by the equation y is equals to mx plus c. So what is the implication? It means we should actually get the gradient. The gradient of what? AD. At the same time, we need to know the C. C is actually your y-cut. It's where the graph of AD will cut the the y-axis. Okay. Then X and Y is any point on the line. And then if you check X and Y, we already have that because on AD, we already have A. So it means our X is -2 and our Y is 2. Okay. And remember, that is why I underlined it at the beginning. AD is parallel to BC. I said parallel lines in this case will tell us something about the gradients. So gradient of AD is the same as gradient of BC. So it means we already have the gradient because we have already calculated it. So the gradient of BC will be equal to the gradient of AD. Okay, the only thing that is left, it becomes a C variable equation. The only thing that is left is C. And then if we find C, then it means we have the equation. Okay. Now let's check. AD and BD, they have a relationship because they are parallel to one another. Okay. What is the relationship that they have? Their gradients are equal because they are parallel to one another. And remember, MAD, it's actually the gradient of the red line, which is AD, and then MBC is actually the gradient of the yellow line, which is BC. Okay. So now we don't need BC for now because we are looking at the equation of AD. All right. Now let's check. How do we start? The solution is very simple. We are not going to calculate. We are going to use the principle. We are going to use what we know about parallel lines. Okay. To say the gradient of AD is equal to the gradient of BC. And we have already calculated the gradient of BC in 3.1, which is 4 divided by 3. And you should put your reason inside the brackets because you can't just say this is equal to 4 divided by 3 without any reason. Okay. Now, what are we going to do? We know the equation is y is equal to mx plus c. We just substitute our m with 4 divided by 3. Then you have y is equal to 4 divided by 3 plus 4 divided by 3x plus c. But I've indicated already that the x and the y is any point, okay, on the line that is defined by this equation. And then the line that is defined by this equation is this one, is AD, okay? Right, let's check it. Now you substitute. You must indicate which point you are using because somebody can still decide to say I'm using D. If you use D, then you're gonna hang in the air because you don't know the value of x, you don't know the value of y. Somebody might say I want to use n because a, n, and d are collinear, but with n you have only one value. What are you going to do with t? So the only point that will help us is a. That is why you write it here to show that you substituted y with 2 and then you substituted x with -1. All right, therefore it means our c is equals to 14 divided by 3. Therefore, it means y is equals to 4 divided by 3x plus 14 divided by 3. This becomes our equation. Okay. Now, how do we mark it? You'll get a mark for using the principle, for using the fact that parallel lines have the same gradient. You get a mark for the gradient. Okay. You also get a mark of substituting any point. Substituting the value of x and y, okay, in the equation. And then from there you play your maths, then from there we give you a mark for the final solution. How hard is that? Very simple, okay. Fellows, remember, when you solve a mathematical problem, you should be sober. That is the first thing. And then you should relax. Don't solve the problems in hurry because if you solve problems in hurry, then you're gonna make mistakes somewhere. All right. Now, let's move on. That is how you get the 3 marks. Then let's check 3.3. 3.3 says determine the value of t. You determine the value of t. Remember, t is a point on AD, and we already have the equation for AD. And then A and D are collinear. They all lie on the same straight line. And we know the value of y, because this is the x-intercept. The only value that we don't know is t. So the same way that you used a with coordinates minus 2 and 2, this is how you're going to use n with coordinates t and 0, because we want t. Okay, so we are just going to substitute this point in the equation that we have just found. It's very simple. Okay, so let's check how many marks is that. You have 2 marks. That is why it's very simple. Okay, let's check our solution. Remember, this is the equation for this line AD, and this point that you see here, nt, is the one that we're going to use to substitute there. This is the one I'm talking about. You know, this is the very same point we're talking about. Okay, so where you see y, you put 0. Where you see x, you put t. Then you have a t variable equation, simple linear equation. Then you can determine the value of t. Okay, right, that is the 0 that was substituted there, and then that is the t that was substituted in place of x. Okay, now you can take 4 minus 3 to the other side. It becomes negative. Then from there you can multiply by the reciprocal of 4. Remember, a number multiplied by its reciprocal will always give you 1, and 1 multiplied by any number, it will remain that number. Okay, so if we multiply both sides by a reciprocal of 4 divided by 3, then it means we'll have t times 1, then we'll remain with the t that we want. Okay, or you can cross multiply, play around, it doesn't matter. Or you can divide the right hand side with 4 divided by 3, it will still give you the same answer. Then your answer is minus 14 divided by 4. If you leave it like this, you lose a mark. Every time write your answers in the simplified form. Okay, right, then the equivalent fraction of minus 14 divided by 4, the biggest number that can divide in 14 and 4 and leave a remainder of 0, and then that will be 2. Then you have t is equals to minus 7 divided by 2. Remember, n is cutting the negative x-axis. X is supposed to be negative, then this is by default logical. Okay, t is minus 7 divided by 2. There is no need to write this in a decimal form. Just leave it like that as a fraction, unless the question dictates that you should round it off to a particular number of decimal places. Okay, we can actually mark it. You get a mark for substituting the point n with coordinates t and 0, and then from there you get a mark for the final solution. How hard is that? Very, very simple. Okay, so let's check what we've actually underlined thus far. We've already used this in our solution in 3.2. We have already used this one in 3.3. We are left with a question related to d and d with coordinates x and y. Okay, let's go on. That is how you get your 2 marks. Right, this is 3.4. Calculate the length of AN. How many marks is this? 2 marks. Okay, calculate the length of AN. AN. This is very simple because this is actually a grade 10 work. Okay, AN. If you say length, it means the distance between the 2 points. You see, and then you have calculated the distance between 2 endpoints in grade 10. And then as long as you know both coordinates, then it means can solve. Remember, we found the value of t. It means now we know the coordinates of n. Then we can just use the distance formula. That is why it's 2 marks. Okay. Remember n. T was found to be minus 7 divided by 2. So let me just put it here so that you remember. Okay. So now, what do we do? Length. It means distance. So you must choose the correct formula. Okay. Let's label x1, y1, and then x2, y2. That is the first step. Okay. Write down the correct formula. Okay. And then substitute accordingly. and then play your maths. You just use your calculator there, okay? But now you should check. This is the substitution. You get x2 is minus 2, and then minus 7 divided by 2 is your x1, y2 it's 2, and then y1 is 0, okay? Now if you use your calculator, you get the square root of 25 divided by 4, then you simplify it. This will give you 5 divided by 2. That is the distance, which is 2.5, okay? 2.5 units. 2 marks. How do you get the mark? Get a mark for substituting into the correct formula. The correct formula in this case is what? Distance formula. Why? Because we're talking about length. So the language is important. Length, distance, okay? Yeah. And then from there you get a mark for the final solution, okay? I don't see a problem there. Let's move on. That is how you get your 2 marks, okay? 3.5. If it is a condition, if DC is defined by, remember, we are saying if DC, if DC is defined by this equation, y is equal, we already know the equation of AD, we know the equation of BC, and then now we are now given the equation of DC, okay? Determine the coordinates of D. This is exactly what I was talking about. To say at the point of intersection, the equations of the two lines that are intersecting at that point are equal. So now that we are given the equation of DC and we know the equation of AD, we just equate them. Then from there we solve them simultaneously, then we get the value of X and the value of Y, okay? This is 4 marks, okay? Now at D, we know the equation which is given, the equation of DC must be the equation of what? Of AD, and the equation of AD, you remember we calculated it in 3.2, which is 4 divided by 3x plus 14 divided by 3. Yeah. You see that point is the D that we're talking about. That is the point of intersection, okay? And then we have our line there, which is AD, and that is the equation for AD, okay? And then we have our line. No, that is a wrong line. It's not supposed to be that one. This is the equation of this line, okay? Pardon me for that. It's not for BC. It's for DC. Right. Right. We just equate them. What is important is equating them. From there you group like terms together. You play your maths. You simplify. Then X will be equals to minus 8. Remember, in the third quadrant, X is negative and Y is negative. So this is logical, okay? Then what do? You take minus 8 and substitute it in any of the equation because they are equal at this point, okay? So you can either substitute it in 3 divided by 8x minus 3, or you can substitute it in 4 divided by 3 x plus 14 divided by 3. The answer will still be the same. But it is important to choose a simplified version of the equation. Like here, if you check, you are having many fractions here. But if you check the first one, is going to be easy because you already have 8. You know, 8 into becomes very simple. Okay, you can tell that this is minus 6, right? So I choose to substitute it in 3 divided by 8 because this is minus 8. Okay, it's just a calculated decision. Okay. Then you have 3 divided by minus 8. The minus 8 that you see is this one that we have just calculated. Then minus 8 divided by 8 is minus 1. Minus 1 multiplied by 3 is minus 3. Minus 3 minus 3, then that will give you minus 6. As a result, it means D has coordinates minus 8 and minus 6, which is valid. Okay. Now let's check, how do we actually mark this? You get a mark for equating the two equations. You get a mark for simplification. You'll get a mark for the value of X. You'll also get the mark for the value of Y. Okay. So sometimes the examiner would say a mark for equating, and a mark for simplification, a mark for the value of x, and the mark for the value of y, but marking it from this point to say the D as a point with correct coordinates, but we'll be looking at -6 specifically. Okay. Now we are covered with that part, which is what we wanted. Okay. Then what more can we get? Let's check 3.6. Okay. That is how you get your 4 marks. Now here is your 3.6. Prove that ABCD is a parallelogram. How many marks is this? 3. Okay. Now it is important, fellows, to review the properties of quadrilaterals. You should also review properties of triangles, the theorems related to triangles, and every time when you give properties of quadrilaterals, there are 3 main things that you actually talk about. You give the properties looking at the sides of the shape, you give properties looking at the diagonals of a shape, and then you also give properties looking at the interior angles of that particular shape. So in this case, we have quadrilateral A, B, C, D. We know nothing about angles, therefore we cannot actually prove looking at angles, you understand? But we actually have sides. Some of them we have already calculated. We can actually talk about that. We also have diagonals in this case. Okay, so let's check. A parallelogram is a closed 4-sided geometric shape that has 4 sides. Okay, and the opposite, it has 2 pairs of opposite sides that are parallel to one another. That is a parallelogram. That is when we talk about sides. Okay, we also know that the opposite angles of a parallelogram are equal, but the angles are not going to tell us, are not going to help us with anything in here, so let's just discard them. Okay, and we also know that the diagonals of a parallelogram bisect one another. Okay, we know that the diagonals of a parallelogram bisect one another. So now, in order for us to prove, is either we will actually look at the diagonals, or we can actually look at the sides. The sides are supposed to be, the opposite sides are supposed to be parallel to one another. So there are 2 conditions that we can use here. If one pair of opposite sides are parallel and equal, then by default the remaining pair will also be parallel and equal. Or if both pairs of opposite sides are parallel, then it means it's a parallelogram. So I will choose to prove that 2 opposite sides are parallel and equal, because we are already given that AD is parallel to BC. So if we can prove that AD is equal to BC, then this becomes a parallelogram. Or we can actually determine the gradient of BC and the gradient of DC. If they are equal, it means these 2 sides are parallel, then it means 2 pairs of opposite sides are parallel. But now in this case, let's choose to find the length of AD and the length of BC, because we know the coordinates of both points. Okay, D is -8 and -6. Okay, right, distance formula AD, substitute accordingly, and then from there you get your value of AD to be 10 units. Okay, remember, you'll just label my x2 here. In this case, this point is x2, y2, and then this one is x1, y1. Okay, x2 minus 2 minus 8, and then whole squared, plus 2 minus 6 whole squared. Okay, this one, be careful here, this is a typing error. It's supposed to be 2 minus 6, 2 plus 6. Okay, this is an error. It should be 2 plus 6. Okay, calculations are based on 2 plus 6, because 2 plus 6 is 8, 8 squared is 64. Okay, that is exactly what happened here. All right, it's 2 plus 6. All right, the square root of 100, this is equals to 10. Okay, then now you check. This is the line that we're talking about. Okay, this 10 represent that line, this 10 units. Okay, so it's 10 units, and then it's represented by that value. We can also determine what the length of BC, substitute accordingly. Okay, so in this case I chose my x2 to be at B, x2 y2, and then at C x1 y1. Okay, substitute accordingly, then you play your maths. Okay, and from there your BC is equals to 10. Okay, we are now looking at BC, that line, that orange line. It is also 10 units. That 10 units is the one that you see there. So it means this, what is the implication? It means these two lines are parallel and they are also equal. Okay, right. Now it means AD is equals to BC. BC is equals to AD. All right. But we know that AD is parallel to BC because it's given. Here it is. It's given. AD is parallel to this. That is what we know. So they are equal. They are also parallel. Therefore, it means this is a parallelogram. Okay. So it means therefore ABCD is a parallelogram. But you should also write your reason to say two opposite sides are equal and parallel. So it means conditions to make, when looking at the sides, conditions that can actually make a quadrilateral to be a parallelogram, or that will qualify a quadrilateral to be a parallelogram, is when one pair of opposite sides are parallel and equal. Okay, or two pairs of opposite sides being parallel, then it will be a parallelogram. Okay, so this part that you see there, it is guided by those notations to say they are equal and parallel. Two opposite sides equal and parallel. Okay. You get a mark for the value of AD, you get a mark for the value of BC, and then you also get a mark for conclusion with correct reason. Okay. Conclusion with correct reason. Very simple. Okay. That is how you get your 3 marks. Now, let's check. Calculate the coordinates of M. Remember, ABCD is a parallelogram. So it means M is the midpoint. Because if this is a parallel, if ABCD is a parallelogram, it means AC bisect BD. It cuts BD into 2 equal segments. It means DM is equals to BM. At the same time, BD bisect AC. It means AM is equals to CM. Okay, therefore it's a midpoint. M is the midpoint of AC, at the same time is the midpoint of BD. So in order to determine M, is going to be very simple because we're going to use the midpoint formula. So you can just choose which line you want to use. You can either use AC or you can use BD. So I'm going to use AC. It's the smallest. Okay. These 3 marks, you just write down the formula, because we know bisect means it will actually when you say M is the midpoint of AC, it is because diagonals bisect. Why? Because this is a parallelogram. We have proven that in 3.6. Okay, but what do we mean when we say it bisects? It means MB is equals to DM, and at the same time AM is equals to MC. Okay, remember this is a parallelogram. Put down the formula. You label your coordinates, x1, y1, x2, y2, substitute accordingly, simple arithmetic, then from there it means the coordinates of M. Remember, M is in the 3rd quadrant. X must be negative, and then Y must also be negative. So this is logical. M has the coordinates -1 and minus half. Okay. So that point there is the M we're talking about, which is -1 and minus half. Right. Get a mark for substituting into the correct formula. You get a mark for the value of X, and then you also get a mark for the value of Y, because the question says calculate the coordinates, and coordinates, it must be the value of X and Y. So you must actually get credits for each coordinate. Okay, very simple. That is how you get your 3 marks. The total marks for this question alone is 19 marks. So just imagine if you were writing a test out of 100 and then you get 19 marks. It means you are left with 11 marks to get level 2 in mathematics. If it was out of 50, it means you are left with 1 mark to get a level 3. Okay, so if it was out of 150, it means you need 45 marks in order to get a level 2. So it means you are actually left with 26 marks, something like that. 26 marks to get a level. So you get almost more than 50% of a particular level with only 1 question. So people remember all these things: midpoint formula, gradient formula, distance formula. At the point of intersection, the equations of the lines that are intersecting are equal. For x-intercept, y is 0. For y-intercept, x is 0. Gradients of parallel lines are equal, and then the product of the gradient of perpendicular lines will always be equal to -1. A number multiplied by its reciprocal is always equal to 1. Diagonals of a parallelogram bisect each other, and the opposite sides of the two pairs of opposite sides of a parallelogram are parallel. Okay, and there are 2 conditions pertaining sides of a quadrilateral that will actually qualify it to be a parallelogram. It's when both pairs of opposite sides are parallel, or when one pair of opposite sides are equal and parallel. 19 marks is a lot of marks, people. Maybe you don't see it. Let me zoom it. Look at it. That is a lot of marks. Okay.